Vector calculus. And there are four main topics in vector calculus. First one is gradient and directional derivative, divergence, curl, rotational and solenoid, vector field, line, surface, volume integral. That's theorems. And let's go to gradient. Before going to gradient, let us discuss it is vector calculus. Actually, in vector we have three types, which we have learned in class 10 and 12. One is general method, and second one is dot product, and third one is cross product. The general method, which we do here in this chapter, as dou by dou x, dou by dou y, dou by dou z plus I cap j cap something. It is a general method, which means we used to substitute something in this one, in this method. Okay, and in dot product we know that dot product, as we learn in cross product, determinant I j we use, we will learn in the further classes. Let us go to del. We are introducing a new quantity called del, which is equals to I cap of dou by dou x plus j cap of dou by dou y plus k cap of dou by dou z. It is a differentiate part, which we use to differentiate in this dy dx of any scalar quantity. Yes, scalar. We differentiate with respect to z, y and x. As vector is a three-dimensional, so we use a three differentiation. I, j, k cap represent the axis. Gradient. To remember, just remember, gradient is a general method which we use in vector. General method which we use in vectors. Class 10 and 12 we use no. Just we substitute in that one and we get the answer. In the same way, gradient is substituting all where phi is a scalar quantity, and we are substituting scalar in this del, which we get a vector quantity. Here we get a vector quantity. That means gradient is a vector quantity, which is a general method which we use in vectors. If you are good in class 10 and 12 in vector quantities, you may get it easily. And directional derivatives means it is the gradient which we have to give direction to the derivative form. Means we have to give the directional vector to the gradient, which we get gradient of phi. Here a cap, which represent, let us xi plus yj plus zk, and a equals to square root of a square plus x square plus y square plus z square. And n cap is a normal vector. Remember that the maximum direction derivative is mod of red phi. Remember this. And if two surfaces are given and we have to find this is a surface and it is a surface, which we have to find the direction of the derivative in this two form. If here is theta, then cos theta equals to del phi 1 plus into del phi 2 by mod of del phi 1 mod of del phi 2. Remember, sigma I cap dou by dou x is equals to this one, because we are adding the sigma part. Sigma. If we add sigma, we have to add everything, no? Yeah. And here are the some quantities which we have to know. Del phi, whose are three components. If phi is constant number, del phi equals to 0, because a differentiation of any constant d by dx of constant is equals to 0. In the same way, dou by dou x of any constant k is also equals to 0 over R. And third one, you should not write that the del phi equals to phi del, because if we write del phi means we will write in this form. But whereas phi of del means phi dou by dou x I sigma. Means here scalar came outside. Scalar quantity came out, and we have to differentiate with something. There is nothing, how we will get? So we should not write in vectors. Another point, and this point also we know that if differentiating any constant, for example c1, c2 are constant here. For example, in differentiate we get d by dx of 3x square. Here let us assume 3 is c1, 3 is c1. In the same way we will write as 3 d by dx of x square. We will write this one. So to remove that, the c1 or c2 are constant, we can remove it outside, and we can do del of phi 1 c2 del of phi 2. In the same way, addition also we can do, right? And the product, or if we do del of phi 1 phi 2, means del is a differentiation of three quantities. Three quantities differentiation is del. In the same way, if two scalar quantities phi 1 and phi 2 are given here, we know that d by dx of uv formula. Do you remember? I will write here u v dash plus v u dash is differentiation of a constant quantity. In the same way, let us assume u and v. Means this one becomes, this is phi 1, this is phi 2. Phi 1, phi 2, phi 1 differentiation. Differentiation means here we have three quantities, so we are introducing them. It is u by v formula only, you can easily do. And let us go to the problem number 1. Before going to the problem number 1, let us discuss that. Here we have given phi of x, y, z. Means phi is a scalar, a quantity in x, y and z. It is not a constant. It is some value in x, y and z. We don't know that one. But here it is given is constant. Means it is a constant quantity. Sorry guys, it is a constant. We have now only read that differentiation of any constant k is equals to 0. In the same way, we will get here 0. Here it is given that del phi equals to x comma x into y into z. Then find del of phi. We know that del of phi equals to I dx, I dy, I z, k dz. Phi, differentiate phi. If we differentiate phi, we will get x, y, z. Phi equals to x, y, Z sigma, let us test sigma I cap of dou by dou x of x, y and z. Here y and z are common constant, which means not constant, which are not differentiable. Let us remove them outside. We will get yz I dx by dx. Sigma will be here, don't forget sigma, and dy dx cancel, and we get sigma of yz. Sigma of yz means yz I cap plus continue xz k cap plus xy k cap. And let us come to the next problem. Here given log of x square, log of x square, y square, z square. Find phi of x. It is a basic problem and the first problem to us. Let us discuss in the next video.